Hello, students. My name is Sonia Malik. I am your coding teacher and mentor. So, in this lecture, you will be understanding what are vectors and various inbuilt functions of vectors like size, begin, end, front, back, push back, pop back, clear, sort, swap, reverse, max size, resize. Hello students, in this lecture we will be understanding about vectors. We will be understanding what are vectors in C++ language, right? Okay, so let us proceed further. Okay, let me take you to the open board. Vectors in C++ language. Vectors in C++, right? So vectors are basically the dynamic arrays. Dynamic arrays. Why? Because the size is allocated allocated dynamically or at the runtime. Okay, now what is the need to study, like you have studied in the previous session, like arrays are doing static allocation. Arrays do static allocation of memory. Vectors do dynamic allocation. Vectors do dynamic allocation, arrays do static allocation. In arrays, the size should be known at the compile time. In it, in this vectors, the size can be allocated at the runtime, at the final execution of the program. Okay, right? Okay. So we arrays are nothing but vectors are nothing but arrays only. Vectors is equal to arrays. Vectors are nothing but vectors are arrays only, but they are dynamic arrays, flexible. In previous lecture, I told you that if array is given the size is 5, it cannot hold more elements. It cannot hold more elements because its size is fixed, that is 5. Size is fixed. It means array is not flexible. Array is not flexible because it cannot adapt more elements in it. I told you, na, like what is the meaning of flexibility, which can change with the changing environment, which can adapt more elements. If array size is 5 and we are giving it one more element, it is not accepting that. It is saying that you have given size as 5 and you are just putting one more element. We are having no memory. Either create a new array or resize this array by one more element. So due to some drawbacks of arrays, due to some size drawbacks, basically due to some size drawbacks in array, one second, drawbacks in arrays, due to some size drawbacks in arrays we need vectors, because vectors are flexible in nature. Vectors are flexible in nature. They can accept as many elements, but to a limit, but that limit is very high. You will not be soon getting to up to that limit. Okay, so vector is flexible. It is like array is like, okay, this is array, suppose this is array, this is vector. You're adding element, and very soon this array will say, oh, my size is filled full now. You cannot give more elements to me. I'm not flexible, I'm fixed size. But these vectors are always accepted in like they always accept newer elements. If you give it this, accept. If you give it this, accepted, but to a limit. But that limit is quite high, and you can like this limit is very very high. It means you can add more and more number elements to this vector. This is flexible. Although it is having some limit, we will be knowing it what it is. What is it? It is also having some limit, but that limit is quite high. You will not be reaching that limit even after putting so many elements flexibly in this vector. Okay, this limit is quite high, so you can comfortably put as many elements you want in the vector, because vectors are flexible in nature. Vectors are flexible in nature, that's why, right? Vectors are flexible in nature. Okay, okay. So now vectors are also having same properties. It is also having zero based indexing. It is also having one based indexing. Same, everything same. Because they are arrays only, but flexible in nature. You know, like what is the main difference between vectors and array? Arrays are of fixed size. Arrays are of fixed size. But vectors are flexible in nature. Vectors are flexible in nature, right? Second thing is, vectors contain some inbuilt functions that we can use as it is. Vectors have some inbuilt, some very interesting inbuilt functions that we can use as it is. One liner functions, just one liner functions, right? One liner functions, okay? So don't think that vector is something very different from arrays. Why I am covering this topic now, because I know that you are very much familiar with arrays, and then vectors are arrays only, but they are having dynamic size, they are flexible, that is the difference only. So you can cover, because vectors are arrays only, right? That's why I'm teaching them one after the other, right? Okay. Okay. So now view, in order to use vectors or work with vectors, in order to work with vectors or use vectors, you have to include some header file. Either you have to include hash include bits std, bits std c++.h. This is the header file which will provide you or allow you to use this vector. Okay, because these are these have to be imported. These are not given by nature. Like int arr, you can create without using any header file, special header file. You can just with iostream you can work with arrays, but in order to work with vectors, these have to be imported by some special header files. Either you can include this universal header file, because you know that this is universal header file, it has so many rich functions. But if you're not using this bits std and you're using this iostream, then you have to specially include header file of vector to access these properties. What is it? Include vector. Include vector. This you have to include. Only then you can work with vectors or use its inbuilt functions. Like for power function, for implementing power function, you are including some library as include math.h. Math.h, right? For using sorting and swapping algorithms, sort, swap, reverse algorithms, you're including this header file. Include algorithm. Hash include algorithm, right? So in order to work with vectors, you have to include this header file. If not want to include this header file, if you don't wish to include this header file, then you can use this universal header file. Okay, if you don't wish to use these many, then use just one header file. Okay, I hope this thing is clear to you. Now let us discuss how to traverse an array, how to access the elements and things like that. Okay. Okay, at every step I will be comparing these vectors with arrays only, like how this is different from arrays, then in vectors how the similarities are there, like what are the similarities. Okay, so there are some inbuilt functions, so one by one we will be covering each, and these are very small inbuilt functions. So one by one we will be covering each and every inbuilt function, right? Each and every inbuilt function, and we will be seeing like in the editor, like how these functions will work. Okay. Okay, first is declaring a vector. Declaring a vector. Declaring and initializing. Declaring and initializing this vector. How to declare and initialize? How you used to declare array? Tell me quickly. Data type, array name, square braces, size equal to curly braces, and the elements. This was a simple declaration and initialization of array, if I am not wrong. Am I correct in saying that? Yes. This was a declaration, na? Now let us see how vectors are declared and initialized. You have to use vector keyword, open angular parenthesis, Use the data type that you want, that is integer data type, and then write the vector name, let us say ARR, open curly braces and put elements as many as you wish to. This is the syntax of declaring a vector. This is the syntax of declaring a vector. Okay, fine. Now vectors are also homogeneous in nature. They are also homogeneous in nature. Like I am saying, na, like vectors are arrays only. I mean it. I seriously mean it that vectors are arrays. It's just about the size concerns. Otherwise vector is array only, right? So whatever properties an array is having, the same properties vector also having. If there are multiple types of array, integer array, character array, string array, then there are multiple types of vectors also. Integer vector, string vector. We will be discussing it. Don't worry. Okay, whatever properties you are having with arrays, the same properties are reciprocated to vectors only, but they are having something rich, some extra things. We will be discussing them. Okay, they are also homogeneous. It means if your initialized vector data type as int, you cannot store a string or char in this. What do I mean by saying that? Suppose if you have initialized this vector as int, na, int then name, then you can only use the integer. You cannot introduce a character. You cannot introduce a 10.5 as a float value. You cannot use string current, because these are also homogeneous in nature, because these are arrays only. Okay, so what are the different types of vectors? Quickly discuss it up, because it is same like arrays. Nothing changed. Different types of vectors. Different types of vectors. Integer vector. How to declare integer vector? Write the vector keyword int inside this angular parenthesis and then vector name, suppose ARR or VEC, something like that. Okay, this will be storing integers only. Another is character vector. Vector angular braces char ARR, store the characters in it. C A P cap. Float vector, same way. String vector, same way. Double vector, long vector, same way. Nothing changed. Boolean vector, nothing changed. True false, something like that. Vector of boolean, nothing changed. Okay, nothing changed. Vectors are arrays only, but the size changes. Changes are there, right? Dynamic allocation and static allocation, this is the difference only. Now, if I am giving you some array as int ARR of size 5, 1, 2, 3, 4, 5, how you used to traverse over it? You are using some variable int I is equal to 0, or especially just doing like this. You are using a for keyword. You are using I starts from 0th index, I goes to the last index, I plus plus. See out ARR of I, where ARR is the name of the array. This is how you used to traverse. This is how you used to traverse inside the array. Am I wrong in saying that? No, I am not. Okay. So this is how you traverse inside the array. Just with slight changes, you can traverse inside the vector also. Let us see. I am declaring a vector of integer. So write, open angular braces and write integer int, write some name, do like this. Same way, nothing changed. No very big difference in declaring array and vector, right? Now, now the how to traverse, the way of traversing changes. Okay, once you will understand and learn this way, na, you will be getting very much use of it. Like you will be using it very much in problem solving. Understand it, learn this syntax, right? Understand the syntax and learn this syntax, like how to traverse. Use a for keyword because for loops are used. auto, auto, it, or I, something like that. Okay, auto, I equals to arr dot begin. I will be explaining you what changes we had. I not equal to arr dot end I plus plus. Open curly braces. See out. See out. Now what you will do? What you will do? Tell me quickly. What you will do? You will do something like star I. This is how you print the value of this I. Okay, this is how you will print something. This is how. Okay, this is the first syntax. But for now, I will not be complicating you with this thing. I will not be complicating you with this thing. So let us use a simple syntax. As you are traversing in the array now, you have to same way traverse inside the vector. Suppose this is array. Okay, int I for I equal to 0, I less than n, I plus plus, C out arr of I. Okay, C out arr of I. This is how you're traversing inside the array. Same way you can traverse inside the vector too. This is a simple way. The earlier was the complex way. We will not be covering, just showing you the like this can also be happen. Vector int arr. Just change this int arr to vector int arr and everything will be same. This will be same. Everything will be same. Nothing changed. This is how you traverse in the vector using inside the vector. The previous way was complex way. We will not be covering it in today. We will be covering it in later sessions, right? When I'll be teaching you about STL, right? Okay. So this is vector. This is vector, right? The same way you can traverse. This is dynamic array basically, right? Okay. Fine. Let us move to the editor to code this up. Let us move to the editor. Let us write the vector. Vector int arr equals to, suppose I'm taking 1, 2, 3, 4. Okay. You can traverse the same way. Int I for I equals to 0, I less than. Now let me take you back to the editor, the open mode. For calculating, see carefully, for calculating the size of array, you use the formula. Now you will be understanding like how vectors are very good and rich in functions, how they contain rich inbuilt functions. Earlier you were calculating the size of array by this formula, int n equals to size of array, size of arr, where arr is the name of array, divided by size of arr 0. You are calculating the size by this long formula, but in vector you just have to write something like this. Suppose this is the name of the vector. Suppose this is vector. Vector int arr is equal to 1, 2, 3. Suppose this is vector. Can you imagine how you calculate the size of this vector? By using just 1, 2 words. You will write something like arr dot size. Yes, my dear students, arr dot size. See, this formula is so big. This is the formula to calculate the size of array. This is the simple formula to calculate the size of vector. So dot size, this size function is the first inbuilt function of this vector. I told you, this vector is having so many rich inbuilt functions. This is one of them. Dot size. By arr dot size, you can easily calculate the size. Okay. So I will be starting iterating from this 0, where I'll be iterating it up to arr dot size. Like you used to write in array like this, na? Okay. Yeah. Suppose this was the array. Suppose this was the array, this was some size 1 2 3. Suppose this was 3 size. So in the for loop you used to write something like this. In the array you used to write something like this. Int I starts from 0, I less than n, or less than equal to n minus 1. This is something that you write. Okay, this is something that you are writing. In the previous sessions I told you na, you're writing something like this na, I less than equal to n minus 1, or I less than n. Both formulas are correct. I less than n, I less than equal to n minus 1. This is what you have to, you were writing in the previous lectures, when we coded using arrays, right? This was the for loop that you have used. This was the for loop that we have used. What? I starts from 0th index. I is going to the last index. I plus plus. This was the approach. This was the condition that you were using. Now, why you are using this n? Because this n is given as 3. That is the size of array. But now you are given some vector. Vector int arr. And you are given some elements as 1, 2, 3. I told you how to calculate the size. By doing this, arr dot size. By doing this. So instead of this n, this is the size of array, but I have to iterate over vector. So here you will replace this n by vector size. Vector size. What is the size of vector? By writing arr dot size. By this. Note n. Replace this n with arr dot size, because you're not working with arrays, you're working with vectors. That's why. So write arr dot size here, and then I plus plus. Same logic, nothing changed. Instead of size, just write arr dot size, right? See out arr of I. Same way. Indexing is also a concept in vectors, right? Print it. Let us see what will happen. Ooh, it is getting printed. Like 1, 2, 3, 4 is getting printed, right? Okay. So the first inbuilt function in vectors is size. Okay, you can calculate the size of any vector by using this formula. Vector name dot size. Any vector size you can calculate. Okay, any vector size you can calculate by this. Fine, I hope this thing is clear to you. Now another inbuilt function is max size. Max size. Another inbuilt function is max size. This max size. Previous was size only, and this was the maximum size. It means the maximum capacity of vector. Like I told you in the previous lectures, that vectors are flexible in nature. Vectors are flexible in nature. I told you this thing already. Vectors are flexible in nature. I told you this thing that vectors are flexible in nature. Like whatever you give, they take. Okay, give me, like that. If you give 1, it will store. If you give 2, it will store. If you give 3, it will store. They're flexible. They're saying that give me the numbers, I'll store. Without saying that I am full now, I'm running out of capacity, I cannot. No. I am very flexible person. Give me any number of elements I can store. But I also told you that this vector is also having some limit. But this limit is high. This limit is very much. It is that you can store any number of elements in the vector until it is not reached to this limit, and this limit is very high. It means vector allows you to store more and more number of elements. They are flexible in nature. I'll tell you how to store more and more, don't worry. So like what this max size will do, it will calculate the end capacity, this high limit of this vector, like up to which limit, up to what numbers they can store, how many numbers this vector can store. Okay, fine. Like although the vectors are flexible in nature, although the vectors are flexible in nature, although vectors are flexible, they are accepting more and more number of elements without saying that I am not full, I cannot eat more elements. They are flexible in nature. but they are also having some capacity, but this capacity is very high. It means you can add any number of elements. If you are adding 1000 elements, you will not reach this capacity. This capacity is very high. So I'm saying that all the vectors are flexible, but they are having some capacity. Beyond that, you cannot store numbers, but this capacity is high. It means if this capacity is high, that means you can store more and more number of elements before reaching this capacity. That's why it is said that vectors are flexible, because this capacity, this limit is quite high, and it is not easily reached by storing more and more number of elements. Okay, so we want to know what this limit actually is, what this limit actually is, up to which like how up to which the quantity of numbers can be stored, like how many numbers are stored in vectors. This is the limit. So we can know this limit by this function max size, the maximum capacity. Even after being flexible, what is the maximum capacity of a vector? It is for sure more than arrays, but it is also having some capacity, right? It is more than arrays. So by this function, by doing arr dot max size, with every function of vector, na, you are using this arr dot. It means arr is the name of the vector and dot is something it is used. Arr dot function name, arr dot function name, like that. So with this inbuilt function, you can know like what is the maximum limit of this vector even after it is flexible, right? Let us code this up. So I am writing cout. Suppose let us create some vector, dummy vector. Now let us know what is the capacity, because for knowing the capacity you need arr dot. If you're not initializing, if you're not declaring some vector, you cannot use this arr, no? Arr dot max size. It means if you have created a vector, how many elements it can store, right? What is the capacity? Let us run it off and see. Ooh, see, its capacity is very big actually. It means it can store so many elements. See how big capacity: 461168 601842738903. So many elements, like this number of elements it can store. In real life, when you will be coding, these many elements you are not actually storing. That's why it is said that vectors are flexible, because see, it's kept it, although it is having some capacity, but this capacity is very high. It means you can consider the vector to be flexible, because its limit will be reached when you are storing these many elements, and it is not practically possible to store these many elements, right? So the main so the max size function is helping you to calculate the maximum capacity of this vector, right? Let us move to the next inbuilt function. Let us move to the next inbuilt function. Okay, fine. Let us move to the open board. Who? Cool. So the next is resize. So the next is resize. Okay, resize. Resize. Suppose I am giving a vector int arr equals to 1 2 3. 1 2 3. Okay, 1 2 3. So now as I'm storing this, as I'm declaring three numbers inside this vector, I'm initializing this vector by three numbers. It means its size is 3. I can also resize its size. It means if it is 3, I can resize it to 1. I can resize this size to 1. For that, I have to do something like this. arr dot resize 1. It means now the array elements size will become 1. Now the size will become 1, because I have resized. Resize means already it is given some size, but you can resize. You can change the size with some other size. That is 1. Let us see the practical implementation. So you are given this 1 2 3, and you are having some array size, but you are now resizing it to something small, suppose 1. Now let us print the array elements. Arr dot size, I told you na, instead of an arr dot size. See out arr of I. Let us see what will happen. See, it is storing 1. Why? Because we have resized this 3 size to 1. Okay, we have resized this size to 1. Okay, but we can increase its size again by putting more and more elements, as it is flexible in nature. So this is the function that is resizing, right? Array dot resize. Now front function. This is another inbuilt function, front. Suppose some array is given, some vector is given to you, vector int arr. Okay, vector int arr, right? Okay, suppose it is given as this. You know, like what this front inbuilt function will do? It will give you the front element, the first element of this vector. It will give you the first element of this vector, of the vector. How will you initialize this function? Initiate this function. You will write cout arr dot front. You will write something arr dot front. By this function, you will get this one. You will get this one, the front element of the array. Let us write it. Let us implement it and check if it is actually working like that. Arr dot front. Arr dot front. Let us see. Cool. It is giving us one. As you can see that it is giving us one. It means the front element is given. Right? The front element is given. Okay. Now, same way, there is one back function. Back. As the front function gives you the first element of this vector, the back function gives you the last element of this vector. The back function will give you the last element, that is 4. Let us run this function. Let us run this function. Arr dot back. Let us run this. It should give 3. Yeah, it is giving you the 3 answer, as you can see in the output box, right? Okay, let us study another inbuilt functions. Okay, let us study another inbuilt functions, right? Okay, so this is some array. Suppose this is index 1, this is index 2, this is index 3. If I want to access this data at element at index number 1, if I want to access this at index number 1, what value is present? I was doing in the array something like this. Arr and then index. I'm accessing this index by this. Now in vector you can do same way. Nothing changed. This is vector. You can do same thing, because I know I told you that there is a concept of indexing in vectors also. There is a concept of indexing in vectors also. That's why you can do something like this, right? No worries on that. You can do something like this, no worries, because this is the concept in vectors too. But let us try doing something else. Let us do something as array dot data 1. Let us see what it will give. What is happening? I'm not getting it. I'm not sure like what is the disadvantage, like what is happening with this function. Okay, let us type this function arr of 1. See, it is giving you 2. It means it is accessing that 2, right? It is accessing that first index element. So I was not sure like when I wrote this arr dot data, arr dot data 1, it took me to some other file with the same vector name. Like I have created so many files in my this, like see my cursor, so many files in the dev c++. It was taking me to this file. I'm not sure like why it is taking me to this file, maybe the name is same, that's why something is happening. So I'll tackle this issue, like why it happened, why on this dot data function it took me to that previous file, this file. So I'll handle this later, and I'll tell you in the next session like what is this dot data function, right? Because of this issue is getting created, and it will waste time if I'll think about it, like if I'll tackle this in the live session, right? Like why it happened. Okay, so I'll tackle it myself, and then in the next session I'll be telling you this function, mind this function, right? Ar.data I'll be telling in the next session. Okay, like how it will work, because now it is causing some problem, but I'll tackle it off and then tell you, right? Okay. Okay, so the next function is pushback. Now I told you know that vectors are flexible in nature. Again I'm spelling out array because they're same only, right? Vectors are flexible in nature, like I was telling you know, vectors are flexible in nature. I was telling you vectors are flexible in nature, right? So it means if there is some vector created like with 1 2 3, suppose there is a vector created 1 2 3 1 2 3 with 0 1 2 index. Now if I do something like this na, arr dot push back with 100, you know like what it will do. Suppose this is a vector with name as arr. So can you give some idea like how it will work? Push back means it will add this 100 at the as the last element. Okay, it will, this function will, this is an inbuilt function in vectors which will automatically add this 100 at the last of this array. Now after adding this 100, you know like how will your array will be looking, how your array will be looking, it is 1 2 300. It will be looking something like this. And now there is no need to increase the size by doing n is equal to n plus 1, because it is dynamic, it is flexible, it is automatically increasing its size by 1. Earlier the size was 3, it will automatically become 4, right? Dynamic in nature, because this is dynamic in nature, and memory is allocated at the runtime when the final execution is happening, right? So this was the pushback function. Now there is a function called as pop back. Suppose this is a vector again. These are the small functions that are very crucial actually. When you will be solving problems, you will be using them very frequently, like 50 times in a day also you can use these functions. These are very important function actually, that's why I'm telling. And they're very one liner, and they're very like they're not lengthy, and they're very fruitful, right? Okay, suppose I'm doing arr dot pop back. I just have used this function 10 to 11 times in one program, right? Okay. arr dot pop back. You know like what this pop back will do? It will automatically delete this last element from this array. And after deleting this last element, your vector will look something like as 1, 2. And there is no need to eliminate the size by 1. It will automatically do it like 1, comma 2. It is dynamic in nature. Size is dynamically allocated. It is very flexible. It can increase the size on pushing back. It can decrease the size on popping back, right? This was the pop back function, deleting last element. If this is deleted, your array will become something like this. If you again perform this pop back, this 2 will be deleted. If you again do this pop back, this 1 will be deleted, the last element. Because this was your array, so this was your array, and you, if you have deleted this element, you are left with this element. Now this is the last element. Now again you're doing pop back, then this 2 will be deleted, then you will be left with 1. This is the element, this is the last element. Then again you're doing pushback, this will be deleted, your array will become empty, nothing left, right? So this was the pop back function. I'm sure that now you are familiar with this thing. Okay, now you're having swap functionality with this also. Swap function, you can use swap function with vectors also. Suppose this is your vector 1 comma 2 comma 3. This is 0 index, this is first, this is second. This is your vector, this is your integer vector, this is your integer vector, right? So if you're writing something as swap arr of 0 with arr of 2, then the value at 0th index will be swapped with the value at zeroth index, this value, let me use some other pen, this value will be swapped with this. An array will look like something like this, 3 2 1, because these are swapped. Now this is zeroth index, this is first, this is second. This is how swap will work with vectors. Okay, fine. Okay, now there is some other method that is clear. This is used in binary BFS approach, breadth first search approach. Basically, very often it is used, very often, believe me. Suppose this is your vector, this is your integer vector, vector int arr is equal to 1 comma 2 comma 3, right? This is your vector. If you're doing something like arr dot clear, the contents of your vector will be deleted. The contents means the elements present inside the vector, the contents of the vector will be deleted, deleted, right? Will be deleted. Let us do this. If I'm writing arr dot clear, no need to do a cout because you're performing something, you're not printing something actually, like arr dot clear. And now let me iterate over this array to print the content, if it is getting deleted or not. Quickly cover it up, right? Cout arr of I. Let us print this if it is giving some elements or it will be showing blank answers to us. Let us run this code. Ooh, it is taking time. Now it will be running. Yeah. As you can see, there is a blank. Nothing got printed. There's blank. B-L-A-N-K. Blank. Right? It means clear function actually cleared the contents of this vector. Cleared the contents of this vector, right? Let us quickly move to some other function. Let us move to some other inbuilt function. Next is sort. You can perform sorting with this. Now, the way of using sorting changes from as compared to arrays and as compared to vectors. Okay, like if you were given some array, something like this, 1 comma 2 comma 1 comma 12 comma 24 comma 2, how you performed the sort function? You wrote sort arr comma arr plus n. Okay, you wrote something like this, where n is the size of the array. N is the size of the array. Am I wrong in saying that? No, I am not. Okay, but this function, the way of writing this function changes as compared to vectors. Suppose this is a vector, the same vector 1 12 24 2, same elements. I have to write sort function like this, arr dot begin comma arr dot end. This is the actual way of writing the sort function when it comes to vectors. Begin function points you to the first element of the array. This end function points you to the last element of the array. So by writing this, it is saying that sort from begin to the end. Sort from begin to the end. Sort from begin to the end. Correct? Okay. Fine. Okay. And now this vector has some properties of random accessing. Same as arrays, nothing changed. Random access, traversal, insertions and deletions are taking that time complexity that arrays was taking. This is the problems with vectors also. In vectors, you will be shifting elements like in arrays. So this you can treat as the disadvantages. Internally, they will take some complexity on doing this, right? So this is all about vectors. Just one thing, that you can do something like this. When you have to sort in reverse order na, when you have to, okay, so when you have to reverse the vectors, you can follow the same approach. Arr dot begin, arr dot end. It means reverse from starting to end this function, right? This is the way. This is the way. Fine. I hope that this thing is clear to you. And one more thing, okay. Okay, let us cover that one more thing in the next video. That was that for loop, for IO to IT loop that I told you in the first. Because I know that at this point of time, this might be difficult. So we will cover it in further sessions when you will be getting good grip over some data structures, right? Okay. Okay. So let us wind this session up. I hope that you have got some knowledge about vectors from this array, and it will be good if you will use this inbuilt functions, and there will be one point of time in your life, one moment in your life when you will be using them more often, but because you are enjoying their functionalities and their luxuries, right? You will be like, okay, these functions are really so nice that they are helping us so, these luxurious functions are very nice, right? So as I use it more often, these functions, and you will be using it more often, okay? Because these are really good rich functions that makes our life easy by just one line, right? So this is the session for today. So thank you so much for joining in, and I wish you all the best. Thank you. Bye bye. Have a nice day.